thank you everyone for attending to today's community meetup. This is the first community meetup in a month. The Argilla team has been on holidays. We went to Cuenca for our offsite. And yeah, this is the first community meetup after this offsite. And yeah, today we are very happy because we have people from Datamaran, a company that we have been collaborating with since 1 year ago or even more. And they are going to explain us how they are using Argilla for annotating data and how they are managing their machine learning model lifecycle for ESG. So yeah, the floor is yours, Vincent and Martin. So yeah, thank you for attending today.
Hi, thank you. Let me share my screen and get started. So thank you everyone for joining today. We are for Datamaran, and we are going to present to you our approach to machine learning operations, especially applied to ESG. So ESG stands for environmental, social, and governance, which is often referred to as non-financial risks for companies. Before we get started, quick introduction from us. So my name is Vincent Rizzo. I'm senior engineer at Datamaran, both on software engineering and data science. And I'm now part of the machine learning operations team, working for Datamaran for almost 5 years already. And with me, Martin, if you want to introduce yourself.
Sure, thank you, Vincent. Yeah, I'm Martin. I'm senior data engineer at Datamaran. I believe I've been working at Datamaran for a similar amount of time as you. And yeah, just like Vincent, I'm also working right now at MLOps side of things, and yeah, on the data flow MLOps and that sort of operation at the moment.
All right, so before we get into the weeds of machine learning operations, a quick context and introduction for Datamaran as a company. So the global context for us is that right now we are living many crises, environmental crisis, social unrest, and companies sometimes are reacting to that with greenwashing. But now regulatory bodies are trying to stop a little bit that and scrutinize more corporate reports to make sure that the companies, the big companies, are actually holding to their commitments. One example of that is the recent entry into force of the CSRD in the European Union, the Corporate Sustainability Reporting Directive. And it's an example of regulations that are starting to affect financially and reputationally at the companies, even those that are not only having activities in the EU. So with this context, many big companies are trusting Datamaran to help them with their ESG strategies. So Datamaran is a software as a service company. We sell a platform access to our users to help them navigating this ESG landscape by providing them insights. And we also have many partners, mostly consultants, that are using the tool to speed up and facilitate the process of researching across different industries. So Datamaran, as I said, is a software, so a platform that we're offering to our clients. To explain quickly how it works, we consume some data coming from 3 main sources that you can see on the left. On one side, the companies. So we look at textual data from their financial annual reports or sustainability reports sometimes to capture a little bit the competitive landscape around a given client company. Then we look at regulations, both voluntary, so laws basically, and voluntary is initiatives, so NGOs recommendation texts, and mandatory, so the actual laws that are existing, enforced by the countries. And last one is the news. So we get from online news, we have our news provider, and we try to capture the public opinion on some companies. All of that is textual unstructured data that we feed to our ontology. By ontology, a list of themes or concepts that we maintain, our in-house experts maintain. It goes from human rights to cybersecurity and greenhouse gas emissions, for example. We have over 400 concepts like this And we identify those concepts in the text to then provide more concrete insights. So for example, what impacts is the company having on society and the environment? What are the risks that are exposed to? For example, competitive risks. If a given peer of theirs is committing to ambitious targets, they might lose market shares if they don't do the same. And on the other side, opportunities as well. Most recently, we have integrated a detection of targets. What we mean by targets is we're referring to commitments that companies are claiming to achieve. They are represented by a KPI to achieve by a given deadline, for example. So when Amazon is committing to net zero by 2040, that's an example of a target for us. All of that is given to the clients, and they update their governance to their strategies that will later appear in the next fiscal year in their report, and probably also in news with the people's opinion. So all of that is a loop that is iterating every 6 months or year, let's say, and our clients need to monitor this landscape on a regular basis. So that's, in a nutshell, what we do at Datamaran. So that now Martin is going to explain where we can use Argilla to help us with all these feedback loop that we are getting at Datamaran.
Thank you, Vincent. Yes, so the first piece to actually managing data and ultimately models is managing data sets and the data that we have to work with. So I just wanted to start basically by giving the context of how we use Argilla in Datamaran. I think it's quite relevant as well. It'll be within the MLOps flow that we have built. So the first point I wanted to make, basically, it's about why Argilla. And we have worked in the past with several tools, including more specialized dataset tools like Prodigy. And we have observed a phenomenon where like our annotators tend to prefer or tend to default sometimes to just using a spreadsheet for minor annotation tasks, especially years past. But as we have moved to using more and more data and having bigger models and working on a larger scope, this is quite limiting. And that's why we've tried to find a tool that would suit us. And that's how we came to Argilla. If you can go to the next slide, Vincent. Thank you. So there's just a couple of things within the Argilla environment that really helped us, whereas before it was harder to achieve all of this at once. But most of it boils down to having an interface that it's easy to use and that we can actually share even to external companies if needed, if we have a really large annotation task, that we also have an enforcement of which data we want to be inputted into the data set, which is something you don't have with something as manual as a spreadsheet or other tools. And then in general, just the SDK of Argilla and how we can actually automatize a lot of the processes, because it's quite easy for the developer to plug in flows and to create new data sets and modify the existing ones just from code. Yes, okay, could we go? Thank you. So moving from Argilla, I wanted to put a bit into context. Where are we using Argilla? Because a lot of the use cases actually link into ultimately models and managing large amounts of data. So the first one I wanted to highlight was topic labeling for regulations, which we have touched on before. And the gist with this one is that we are automatically labeling with our ontology certain topics that may be appearing on regulations or initiatives. But this automatic annotation may not always be trustable due to the nature of initiatives and regulations, and we generally want to keep those really polished because they're quite important. So what we do is, after the fact, our regulations team reviews these labels and they make a decision based on the surrounding context and their expertise, ultimately. And Argilla helps us here because it allows us to give them a platform to do this and to link this whole flow into our data pipelines and be able to consume the new data and also make the changes when our annotators actually annotate a topic and propagate it into the production databases. I think in the next slide we have a quick screenshot of the regulations search feature, just to give you a bit of context on, you can see below in the yellowed out section that we have topics that are tagged per each regulation, and this is what we are actually modifying within Argilla and what we have a data set on of manual corrections over automated labeling. Then the other use case that I wanted to mention is news articles quality assurance. And this one boils down to, we consume a lot of news articles and we really want to know which company is the article talking about, because ultimately that's very relevant to whose is this important for, right? Like companies in the same industry, maybe the same company that is a client of ours wants to check that out. But organization detection is not always perfect either, and we want to have kind of an overview and be able to manually correct any problems. So what we are doing now is we are semantically clustering the biggest stories and giving a sample of those to our annotators, which are then able to correct the company assignment. So for instance, if they see an article where there's an ad at the bottom of the text where it's talking about a new Samsung product, the article is not really about Samsung. So they will correct that, and maybe they will eliminate Samsung or add the actual company that the article is talking about. And we incorporate this into our pipeline, which means it's easy to propagate the changes again. And we have a large corpus of manually annotated data that we can rely on later to train any models. And I also have a screenshot for this use case, I believe, where you can see some big kind of news clusters and the organization that they are assigned to, in this case, Meta, which is the thing that we're actually correcting, right? This organization assignment in the dataset that I've mentioned. And then next, we have the kind of final use case I'm going to highlight, and the use case that we're going to pull through to show you the MLOps flow that we have been working on. So basically, this feature is about target detection, which Vincent has mentioned before, putting as an example a net zero commitment by a certain year. And it expands to other areas, but it's a good summary of what you might expect to see. And what we are doing here is that we are combining two approaches. On the one hand, a deep learning model that has been tuned over a number of manually validated report sentences, some of which are targets, some of which are not. And then we have a post-filtering pipeline that has a series of ad hoc rules and basically some mechanisms to avoid false positives and certain structures like verbatim standards that may actually interfere with the model. And I think we also have a screenshot for it. So you can see this is a small screenshot of the feature, and we have targets listed for Meta on the left and then for Amazon on the right side for a specific topic, which is GHG emissions. And our model and the post-filtering pipeline is helping us detect all of this. And this model has been a bigger enterprise for us and has forced us to update our MLOps approach. And it's the one that we are going to use as an example to talk about it. I believe, Vincent, you will take over.
Yes, thank you. Starting to talk about machine learning operation, really. As Martin said, this example of a model is a typical example of a text classification model, where you're trying to detect whether a given sentence is a target or not. And that comes with a lot of challenges. To name a few, here we have the dataset and model versioning. If you want to iterate on the model, you will need to both track how your data is changing and how the different iteration of the model are changing. Then what we call experiment tracking. So not only do you want to separately version your dataset and model, but also you want every model, every version of a model to be linked back to whatever inputs, so dataset and parameters served to generate it. And finally, also, how do you allocate your training resources, as training might be compute expensive, and the default approach would be to train once on a notebook, on SageMaker, on Colab, whatever. But then how do you standardize and how do you allocate regularly the GPUs or CPUs that you need? And the fact that it's ad hoc is always a reason for more friction. So thanks to our collaborators at Mantis and LP, we have built a process that will solve most of those problems. This is a quick summary, high-level view of the loop that we are putting in place. We have in place now on the targets model. And it starts basically at the dataset creation. And then we start training and iterating over the model, constantly monitoring any drifts that we might have on the model. To start, as I said, we will start with dataset creation. In our case, it's looking at sentence extracted from the report. The idea is to make sure that the task is understandable by our annotators, which might be internal annotators from Datamaran, or sometimes we might outsource to external companies to help us with the labeling, which means that it's very important that we are asking a clear question and that the options are quite straightforward. In this example, we are asked to label whether the sentence below is a target or not a target, or what we call a non-specific target, which is a commitment without either a deadline or a KPI to measure it. And that's the first part where Argilla comes into place. Then comes the first training or other training, let's say, and that's where we face most of our problems. As I said before, you need to version your data and your models. And our approach now includes tracking it just as you would do with regular software, so basically using Git, but with an extra flavor to it. We use a tool called DVC. Some of you might know. DVC stands for Data Version Control, and it allows to store big files, to track the modifications on big files. How it works is basically it tracks a hash or a pointer to a remote location, in our case, AWS S3. But this way you have Git operations basically for your machine learning models, and everything is versioned and any modification will be tracked. Then second comes the problem of experiment tracking. As I said, not only do you want each dataset and model to be versioned, but you want to always be able to link a model to the dataset that generated it. So again, DVC helps here. So you can create a pipeline where you define what are the inputs, so the dataset and hyperparameters of the model, for example. You have a training script that will run to generate the model and some outputs, the model and the metrics, to name a few. And a DVC pipeline is a link between all those elements that you can reproduce as you wish, but every state is tracked to avoid rerunning multiple times on the same data. And so whenever the data changes, then a new version is created, but it's always linked to whatever inputs served to create it. And again, as I said, we use the same set of tools, Git, DVC, and S3, to store every outcome of that. Finally, allocating the training resources to solve that problem, as I said, we use Git operations, so we track every modification on our repository, which is stored on Bitbucket in our case. But whenever you push a change to your code, you will start a new continuous integration pipeline on Bitbucket, or it works also with GitHub, of course. And that will use a set of tools called CML, or continuous machine learning, also provided by the same company that provides DVC. And this tool, CML, will serve for spinning up new instances on your cloud. Works with AWS, Amazon G-Cloud, and Azure. And this instance will serve for the training. Once the training is done, you get the metrics back to your host, and the host can put a comment with the changes in the metrics on your pull request, which helps, again, for the experiment tracking and the allocation of resources. You get a report of how the experiment went, and you can make a decision whether you want to push this new version of the model or keep the old one. And so once your new model is created and you're happy with its performance, its quality in general, you can merge your pull requests, which will trigger a deployment automatically also to wherever you want to have your endpoints. In our case, Hugging Face or SageMaker, because we have some infrequent processing, so we tend to prefer serverless inference. And so up to here, yeah, Martin.
Thank you. Yeah, so as Vincent has mentioned, basically the initial training process would end with you deploying the model. But I think that the thing that we struggled initially the most with is actually closing the loop, right? What do you do after that? And ideally, what you want to do is keep monitoring and retraining the model periodically. So this starts with us retrieving data from production or for any streams that we have for it to perform continuous validation, which is the next step. In our case, that also means that we have thought a lot about stratifying the data that we get, particularly because report data is heavily affected by which industry it's from, right? The targets from a medical or a pharmaceutical company do not look the same as ones from a chemical or, for example, oil company. And then aside from this stratifying, we've also delved into topic stratification. And as we've mentioned before, we have an ontology that is divided in categories, and the targets coming from the different categories within the ontology may be very different, as I've just said. So a greenhouse gas emission target may be very different from social responsibility target, for example. So that's the first step, making sure that targets from all the disciplines are well represented. As a default, for example, I can say the greenhouse gas emission targets, because of the way they've gained importance, are overrepresented, right? So we wouldn't want to straight up get all of them. Once we have sampled our data, we can move into the next step, which is annotating the data. And this is again where Argilla comes in because it allows us to seamlessly transfer the data coming from those streams that has been stratified into the Argilla platform, and from there annotators annotate it. For instance, in this particular case, what we do is we would be sampling targets weekly, just a portion of them, obviously not everything that goes through the platform, and then those targets would be annotated by our internal users. Yes, and when this annotation has been done, what we do is both store the monitoring data set for future use in retraining the model and retrieving analytics, and also propagate the changes. This is something that I've already mentioned for initiatives and news, but just basically the idea is that because of the way Argilla works, it's very easy to retrieve the data from there and actually make a change into production if a target is actually the product of an error for the model. So as you can see there, we would just be removing the target, for instance, if it's tagged as not a target. And with this data set, then we move into monitoring. We already have our data, we have annotated it, we are doing it weekly, so we are up to date. And what we are doing in this case is executing an analysis every 2 months over this monitoring data set, which includes both classification metrics, a breakdown of the performance by category, some data regarding keywords and their influence, and then other checks such as adversarial attacks and generally model robustness checks. How does this look? For instance, one of the things we achieve by actually monitoring the model so frequently is that we can react in time when there's a change in how companies are disclosing. So for instance, it could be that it enters in action, which is a specific regulation, or there's a new change that a regulator includes, or there's a new kind of trend within companies that means that they start talking about their targets differently that could throw off our model. In the case that we have here on the right side, it basically says on the top half that we want to cut half of our greenhouse gas emissions between 2030 and 2035, which is not very specific, right? And then because of CSRD, because of other factors, maybe the company has decided to be more specific later, and they might say, hey, we aim for a 50% absolute reduction in scope 1 and 2 emissions by 2030 from a 2023 base year, right? They are quite specific in this case. And so this sort of changes is also what we aim to capture by retraining the model frequently or just monitoring this. Next one, thank you. Other monitoring checks also include adversarial attacks or robustness checks. Here I have two specifically about text quality. The first one is segmenting the sentences differently or incorrectly, basically, to see how the model reacts if the relevant information is still there, but we have segmented the sentence. Does the model still classify it as target? Which is this specific case is very useful for us because we might have corrupted or splitted sentences due to how PDF parsing works and generally how we process a text at the origin. We might have from time to time some errors so it's useful that the model can actually react to those. And then we also have omitting words and substituting by synonyms, which is basically a robustness check. And because ultimately we are trying to ensure that the model can keep working even if there's a change in the language or how something is formulated in the text itself. Next one. And this is basically the last step, right? Once we've Vincent stopped deploying the inference model, and then we've kept going monitoring, right, re-annotating data. And at some point, either when we have enough signals or some kind of strong indicator, right, the model has gone down in quality a lot, for example, or enough time has gone by where we want to try to retrain the model and see how it fares against the previous version, then we would retrain. So this automation that we've talked about will also allow us to, hey, I'm just going to trigger training at some of these points, and I'm going to see how it does. So I think if you go to the next slide, Vincent. Yeah. So some of the examples would be for strong indicators, would be, for example, recall goes down a lot. There's a specific topic, because remember, we are stratifying by topic, right? So there's an area where our targets are not performing well, which we would be able to see because we are first sampling, stratifying, and then annotating weekly. And so we could see, for example, that a cybersecurity topic has 200% more false positives, maybe because there's a new way of talking and there's a new standard that the companies are mentioning, and our model interprets that standard as a target. So then we would have to correct the model, and that would be done normally by retraining over this annotated data that concerns the cybersecurity topic. And with this, we would basically close the loop that Vincent introduced, and we would just start again training, deploying, monitoring, and keeping the model alive, which I think was our most important objective, basically, when constructing the flow. I think that's all from us. If there are any questions.
Okay, so yeah, thank you so much for the presentation. It has been really interesting. And yeah, I really like that you are covering also this monitoring part that many times companies forget about. So yeah, it's cool to see that you are retraining your models and checking that everything is working okay in production. So yeah, there is a question which is quite simple, made by me, and is how did you manage the migration from spreadsheets to Argilla?
I would ask if you mean in terms of existing data sets or just in general, like the way we
in general
work.
Yes, like how you transition from spreadsheet to Argilla, or yes.
I can't really say much, like a lot of bad stuff about it. I think it was mostly about putting processes in place, because with spreadsheets, normally they would be created as needed. So it was like a one-time process or something we would do every once in a while, but that has ad hoc code. Argilla kind of benefits a lot from having some kind of scheduled action where you don't let the data set die. So I think it was also a bit about learning how to keep a process running and do weekly work. We've also done like one-time jobs with Argilla, but I think in that case, it hasn't been too hard, because when we have worked with spreadsheets or Prodigy and whatnot, we were already getting the data using our code. So it's actually better to insert it into Argilla than just dumping it into a spreadsheet. So I would say, I don't know, Vincent, what do you think? For me, it was mostly about like actually having like repeatable processes rather than creating a new data set every time.
Yeah, and in the end, it's about like the annotators. In most cases, they accept what you send them. We create a data set, but whenever an annotator is an expert and has already an idea, when they don't know how to set up an Argilla data set, they would go to a spreadsheet. I guess it depends a little bit who initiates the task, right? If we do, we'll create a task on Argilla and share the link. But then some people that are not initiated to code or to create a dataset through Argilla, they would then with the simple approach with spreadsheet.
Cool. And yeah, I have another question. Yeah, you have been using Argilla for a long time already, and you started with test classification dataset, and I think that you are now using the feedback dataset. So what can you tell us about them?
Yeah, well,
do you like them or not?
Yeah, I think so. I can't say much about the text classification dataset because I think I started using Argilla once the feedback was already there, and from the get-go I started with feedback dataset. But from when I understand, feedback dataset provides more flexibility, and in general we always had this kind of problem where we face some ambiguities in the records that we share with our annotators. There is a text that is quite not clear how I should tag it. So it's always welcome to have extra questions to help gathering annotators' feedback. So free text input, for example, is something that I would include every time on a dataset to be sure that they have the opportunity to give more context around a given example.
Yeah, that's something that we also found. Like you set up a task, for example, just for test classification, but yeah, maybe just having those labels doesn't cover some other problems. So having extra questions can help a lot in the annotation process. Okay, so there are no more questions unless you want to say something else. We will close the session for today. And yeah, thank you so much again, Martin and Vincent, for coming today and presenting what you are doing in Datamaran. And yeah, that's it for today.
Thank you, Gabriel, for having us.
Thank you. Thanks a lot.
See you. Bye.
Bye.
Bye.